Number 1 for the Chapter 2 BAT list is number 25 from page 246. And your directions here say to divide f of x by d of x and write a summary statement in polynomial form. However, for the test, I'm completely okay with fraction form. So that's how I'm going to leave my answer. So to do that, we're going to use synthetic division because we can, because our factor, x minus 3, that we're dividing by is linear. So then remember, you double check your powers, cubed, squared, linear, 0 power, we're good. So that means that we don't need any placeholders. So we have 2, negative 7, 4, negative 5. Bring the 2 down, multiply up, gives us 6. Adding gives us negative 1. Multiply down, bring the product up, gives us negative 3. Add, we get 1. And then 3 times 1 is 3. And we add and get negative 2. So now we translate our answer. So we write in fraction form. Again, this is kind of sidestepping the directions, but I'm okay with that for the test. F of x equals 2x squared minus x plus 1 minus 2 over x minus 3. And that's number 1. Number 2 from your BAT list is number 27 from page 246, and the directions say the same thing here, but on your BAT list I told you to describe end behavior of f of x using limit notation and explain your reasoning. That's all you have to do with this function. Well, remember, for end behavior I only have to look at the first term, which is x to the 4th. When it's written in standard form, you can look at the first term. You're looking for the leading term, which is always the one with the highest exponent. So our degree, and me and the board here aren't working very well together. Hang on. Let's try that again. My degree is 4, which is even. And remember, even functions either do something like this, with some changes in the middle, of course, or something like this. Which one of those they do depends on the leading coefficient, but our leading coefficient here is 1, so we write a equals 1, which is greater than 0. So we know that our end behavior is going to look more like the parent parabola x squared. So we write using limit notation, and since these both go in the same direction, you can write the limit as x approaches plus or minus infinity. So in either direction, f of x has a limit of infinity. And your explanation is what we jotted down in the bullet format. Even degree, positive leading coefficient, both go to positive infinity because we have an even power there as our leading coefficient. All right, or not coefficient, but term, power. All right, number 3 is number 24 from page 225. So we will flip back to page 225 and read our directions there. I'm not sure that's correct, is it? Yeah, it is. Okay. Number 24, we have x plus 2 over x squared plus 2x minus 3. Sorry for the pause. I thought I had made a mistake in my notes about what we were doing here. Okay. On this one, all you have to do is give me the horizontal and vertical asymptotes and justify your choices. So again, anytime we have something like this denominator that's not factored, just go ahead and get in the habit of factoring it out, because we're going to have it in factored form in order to do what we're about to do. So let's set up our factor pairs. The 3 is minus, means that I'm going to have a plus and a minus. I need the pair that multiplies to 3 with a difference of 2. So that's 3 and 1. Always make sure to put the larger number so that it matches the sign of the middle term, and you should be correct in your factorization. All right, now, so we want to look at our horizontal and vertical asymptotes, and whichever form you prefer. For the horizontal asymptote, remember you're looking at top heavy, bottom heavy, or matching degree, and this function is bottom heavy, which means we're going to have as our horizontal asymptote y equals 0, also known as the x-axis. And our vertical asymptote check reveals that we have 2 times that the denominator is equal to 0. So our first vertical asymptote happens at x equals -3, and our second happens at x equals 1. You should always write these as equations of lines because we have one horizontal line and two vertical lines to account for if we had to sketch it. So that's the proper way to do that. And we're done with that one. For number 4 from the BAT list, you are to do number 29 from page 246. And our directions here tell us to use the remainder theorem to find the remainder when f of x is divided by x minus k, and check by using synthetic division. We'll skip that part and just get our remainder. Alright, and I wrote the f of x but did not write what we were dividing by. So number 29, we are dividing by x equals, no, they gave us x equals, but I want us to think of that as a factor there. So we would be dividing to get the k they gave us is -2, so that would make our factor x plus 2 that we're dividing by. So remember, your remainder theorem does not tell you to use synthetic division, it tells you to use f of k. So that's what we're going to be using. So we're going to substitute 2 into the equation. And you should always write the left side, because if you fail to do that, you haven't demonstrated where all your little jotting of numbers is coming from. So we have 3 times 2 cubed minus 2 times 2 squared plus 2 minus 5. Well, 3 times 2 squared is 12, because 2 squared is, I'm sorry, that wasn't squared, it was cubed. Let's try that again. 2 cubed is 8 times 3 is 24, and then 2 squared is 2 times 2 is 8, and then we have plus 2 minus 5 waiting their turn. 24 minus 8 is 16, and then somehow I left my minus 5 off, so let's try that. I mean my plus 2 off. So plus 2 minus 5. There we go. The 2 didn't make it. We'll try again. 24 minus 8 is 16, plus 2 is 18, minus 5 is 13. So our remainder is 13. All right, on to the next one. On number 5, we are to do the exploration on page 160, and the problem says Camelot Apartments bought a $50,000 building and for tax purposes are depreciating it at $2,000 per year over a 25-year period. And then number 1 says, what is the rate of change of the value of the building? Well, the rate of change of the value of the building is the $2,000 per year that it's depreciating, and I will abbreviate that here. So that means that it's $2,000, negative $2,000. And then number 2, and the negative comes from the fact that it's depreciating. That's what that means. It's losing that value. Number 2 says write an equation for the value, and it tells us to call that equation v of t. So a value function depending on time is the importance of that notation, as a linear function of the time t since the building was placed in service. Well, the initial value, which is always your y-intercept, was 50,000, and then this building is losing 2,000 per year, and t is our time in years, so that is our v of t equation. And then 3 says evaluate v of 0 and v of 16, and we're going to omit number 4 from this because you don't have to do that for the test. And this isn't exactly like the problem on the test, but if you can do this one, you should be fine with the one on the test. So v of 0 is 50,000 minus 2,000 times 0, so that would be 50,000. Let's put the dollar sign back on it for our final answer. And then v of 16 would be 50,000. Oops, me and my pen aren't getting along again. Try again. 50,000 minus 2,000 times 16. And obviously you multiply before you subtract. So when we multiply, and let me run to the next screen so we got room to show our work here. We would have 50,000 minus 32,000. And 50,000 minus 32,000 is 18,000. And that is the end of our Chapter 2 BAT List 1 through 5 video.